Welcome back to Maths with Mr. Duffield. Got a problem here that I set to my GE a couple of weeks ago, but it's also applicable to my LE, to my UF. Any GCSE candidate is going to get something out of this. That we are graphing a pair of simultaneous equations to solve them. Talked about simultaneous equations a little while ago. Also talked about gradients and graphs a little while before that. We're just combining both of those elements into a single question here. Finding the point of intersection between two lines, minus x plus y equals 5 and y equals 2x minus 1. I'm going to plot them on this graph. Now, for the sake of making it clear here, I'm going to actually change up the scaling. I think somebody was confused about the fact that the scaling here results in something a bit weird, resulting in the lines kind of going off this grid unless I adjust the y-axis. I'm going to make every square on the y-axis be worth 2 instead of being worth 1. Okay, that might seem a little bit strange, but the reason is that the resulting graphs I'm about to draw, they won't intersect physically on this grid unless I do that. I hope that makes sense. Okay, so let's plot these lines. Well, now I've labelled up the key part of my axes. I mean, if I wanted to, I could label that up as well. Takes a bit of time, but, you know, a bit of clarity never hurt anybody. Let's start with this one. Y equals 2x minus 1. 2x minus 1. Effectively, that means, if we remember, that the 2 in front of the x is the gradient, and minus 1 is the y-intercept. Okay? Gradient we talked about a few videos ago. Every time I step 1 to the right, how many places up or down do I go? And this y-intercept is exactly the place on the y-axis, that the line cuts through. Minus 1, so obviously going to be halfway between the origin and this minus 2 point. So that is the y-intercept. Every time I jump to the right by 1, it goes up by 2. Remember that because of the scaling that I've changed this y-axis to, actually it's half a square that represents a jump up of 1 instead of a whole square. That means that this line is actually going to go through the half square of every sort of jump to the right. If I join all of these points together, I'm going to get hopefully a nice straight line. Just bear with me here. I want to make sure I get this a-okay. There we go. So that is my first line, y equals 2x minus 1. Now the line minus x plus y equals 5, I might rewrite this. I might do something like adding x onto both sides. So I can plot it in a similar way that I did this line by making y effectively the subject of this first equation. The negative x and the positive x cancel, leaving me with y on the left, and then 5 plus x, or as I will write it, x plus 5 is the next one. Okay, that is an equivalent form of this first line equation. Y-intercept again, plus 5, that's going to be there, and then every time it increases by 1, it goes up by 1. Like we said earlier, 1 is half a square. Oh, crumbs, we should be seeing. Yeah. It's laborious. We have to be very, very careful. But you should be seeing the lines meeting at this point here. Look at that. Wow. So, what is that coordinate point that these two lines have met up at? 6 across, and remember we said every half square is 1, halfway between 10 and 12, 11. So 6, 11 is the point of intersection, so the solution to this particular question is 6, 11. Appreciate this is going to be this is a bit of a tricky question because of all of those elements that we've talked about. We need to know about how to plot a straight line graph from the y-intercept and from using the gradient. We need to know, and we need to be confident enough with our grids to change the scaling on the y-axis to make it fit physically on the grid. And we need to know how to rearrange a slightly different straight line equation to make y the subject so that we can produce a straight line graph using this method. Tricky stuff, but very, very doable if you're willing to practice. The rest of this worksheet for my GE is on Teams already. I may well give it to my LE and my UF too. Best of luck, and talk to you soon.